3.7, evaluating determinants and applying Kramer's rule.
Who's Kramer?
We'll talk about it in a minute.
Corey Kramer?
Okay. Associated with each matrix is a real number called a determinant. So a determinant is a real number, okay? So a determinant equals a real number, and it's associated with matrices.
I see what you're doing. As soon as you add a person's name, it just gets harder. Like, I'm not even kidding. It's just facts.
Like Pythagorean. Sure, that was funny.
Okay, so here's the deal. If you have a 2 by 2 matrix, okay, if I have a matrix A, B, C, D, and I want to find the determinant of this, okay, the way you find the determinant, because like I said, it's a real number, okay, that means you're going to get one number as your answer. The way you find a determinant is you take A times D, and you subtract from it C times B.
So there's no matrix in there. Is it just one number?
It's just one number, okay? And you'll get your answer. Now,
Did people mess that up?
people don't mess a 2 by 2 up. We're going to look at a 3 by 3 because for a 3 by 3 you could mess it up, but I'm going to show you how to do it so that you don't mess it up. But it's up to you to write it the correct
so
way.
you multiply A and D together and subtract C and D?
Yes, you're multiplying the diagonals together. Diagonal.
And then you subtract them.
And subtract from it the diagonal this way.
Okay.
We'll do it with real numbers. So let's say you have this.
But you always go from the top left to bottom right first?
Yes.
Okay.
So let's say you have 5, 4, 3, 1. I'm going to take 5 and 1 and multiply it together
That's
and subtract from it 3 times 4, which is,
12.
so what's 5 minus 12?
-7.
That's your determinant. Okay? So you can have negative numbers as your answer. It just has to be a real number.
So as long as it's not decimal?
Unless you're dealing with decimals inside of here, you might have one. Like if I'm dealing with 1/2, 3/4, 5, 6, whatever.
You're gonna have that.
Wait, hang on. What classifies as a real number?
Anything that's not imaginary.
I don't know what that means.
Real number, like a number line.
That falls on.
Think of a number line. You have positive, negative, zeros. You have halves, 3/4, negative half, negative 3/4, negative whatever.
Oh,
That's
so
all.
anything that doesn't have like repeating decimals, right?
Basically, yes.
Okay.
Exactly. Okay. Now, if you have a 3 by 3 matrix, that's where it gets a little trickier. Okay. If I have a 3 by 3, I have something that looks like this: A, B, C, D, E, F, G, H, I. That's my matrix. Okay. Now, on this, we multiplied the diagonals, right?
Yes.
Okay. We multiplied all the diagonals that go from left to right, and then subtracted from them all the diagonals that go from that go up. Okay, so down from up. Okay. Here, if I multiply the diagonals, I get A times E times I. Okay, but this is my problem. Actually, I need more space.
Ooh.
This is my problem.
Okay.
Do you see how I have another diagonal started here?
Yes.
Okay. What you need to do when you do a 3 by 3 matrix, copy the first 2 columns on the outside. That's step 1. Copy the first 2 columns. Because now when I do my diagonal, okay, I'm going to add to this B times F times G. And I'm going to add to this C times D times H. I'm going to subtract from it, okay, the diagonals that go up. GEC plus HFA. This is much easier when you do with numbers. And IDB. So, when you do 2 by 2, it's super simple, right? When you do a 3 by 3, if you do not copy those rows over, or I'm sorry, those columns over, the first 2 columns, then you are going to mess it up. we're gonna take a look at it this way.
Does it matter what order you go in?
Yes.
Okay.
Okay. So what do I need to do on this 3x3 first?
Two
Two,
times
neg-
one
two
times
negative
one.
4, 1, and 3,
Okay. So I copy my first two columns down again.
Yes.
Okay. Once you copy your columns down, you're multiplying the diagonals together and adding them together. What diagonal do I start with?
Two
2,
times one
1.
times negative two.
Okay. So 2 times 1 times negative 2. What is 2 times 1 times negative 2? I'm going to write it over here so
Negative 4.
I have space. And I'm going to add to it what?
Negative 1 times 0 times 3.
Beautiful. So that is what?
0.
Beautiful. Then I'm going to add to it what?
Negative 3.
Negative 3 times 4 times negative 4.
What's negative 3 times 4?
That's a good question.
Positive 12.
No,
Negative
well,
12.
negative 12. And what's negative 12 times negative 4?
Oh, positive 48.
Yes, positive 48. Okay, so I get this. From this, I am now subtracting, and where do I start my diagonal now?
Where the 3 is.
So I cannot even believe these words are going to come out of my mouth.
Okay.
It is really hot in Mrs. Porter's
Okay,
room.
I'll take care of it.
I said to the kids, I said, you will probably never hear me ever say that again.
That's fine.
Thank you.
Yep.
She's our sub today.
Yeah. Really?
Okay, here we go. So what do I need to do?
3,
Multiply what?
3 times 1 times negative
3 times 1 times negative 3. What's 3 times 1 times negative 3?
3. Negative 9.
Negative 9. So this is going to make this right here. Now, negative 4 times 0 times 2.
That'd be
2.
Negative
0.
4 times
negative
0.
8.
0.
0.
Oh, 0.
0.
And then the last one is what? Negative 2.
Negative 2 times 4 times negative 1.
Okay, negative 2 times 4 is,
Negative
and then negative 8 times negative 1.
8.
Okay, so I have that. Now, do you notice how this 4 and this 1 are not used?
8. Yes.
They will never be used. If you use them, you've done something wrong. Okay?
I see what you're saying.
That 4 and 1 will always be there
So
on the
we're
outside.
going to use
Every number but
except
the
for
numbers
Yes.
that are
on the sides.
on the
Except
side.
for the two side middle ones. Okay? Now, what is negative 4 plus 48?
44.
Good. And then I have 44 minus, what's negative 9 plus 8?
Negative
So I have 44 minus 1, which gives me
45.
45, because I put that one negative. And that is your determinant.
Seems easy.
Okay, that's not so
It is easy, it just takes time. Okay?
It's
If you-
just easy to get lost.
Yes, if you
If you mess up once, it's hard to
to correct.
correct.
Exactly. Okay. Now the reason we're learning this is because of this. When you want to map something out, okay? A lot of times things that we go to in life, like if I drive from school to my house and then from my house to the mall, I make a triangle basically. Okay? And you can like map things out. When you're doing stuff that's nautical, okay, like on a ship, whatever, a lot of their stuff is mapped out through triangles or routes that are like that. I can use the determinant to find the area of those triangles when I only have coordinate points. Okay? So if I have coordinates, it's called a area of a triangle coordinate system. How do you usually find an area of a triangle? What's the formula? Okay, so you know that the area of a triangle equals 1/2 base times height. Okay? If you have coordinate points, you can also find the area of a triangle. If you have if you have 3 coordinate points, I can find the area of a triangle. Here's what you're going to do. Okay? If you have 3 points like x1, y1, x2, y2, x3, y3. And it wants you to find the area of that. Okay? what I can do is I can set these coordinate points up in a matrix. Now, here's the deal. You are always going to put a placeholder of 1 over here because you have to have a 3 by 3 matrix because I have 3 points. Okay? So I represent that with a placeholder of 1. When you do this, you told me the area of a triangle is a half base times height. So what do you think you're going to multiply the answer by?
2. Or divide by half.
Yeah, multiply by half, divide by 2. So here's the deal though. Your formula says plus or minus 1/2. Why would it say plus or minus 1/2? What do you think? What do you know about area? It has to be what? Positive. So if I get a negative determinant, I'm going to multiply it by a -1/2 so I can get a positive area. Do you get what I'm saying? Okay. So then we get word problems like this. Whoops. Okay. This word problem says, off the coast of California lies a triangular region off the Pacific Ocean where huge populations of sea lions and seals live. The triangle is formed by imaginary lines connecting Bodega Bay, the Farallon Islands, and Ananuevo Island, as shown in this diagram. And it's listed as this. The points are -141, 38, -43, and the third point is 0, 0. And it says, use a determinant to estimate the area of this region that these sea lions and seals live in. So I'm going to set up a determinant. It doesn't matter which one's x1, x2, or x3. As long as whatever x1 is, y1 goes with it. Okay? So I'm going to say -141, 38, -43, and 0, 0. What else do I have to put with this?
1.
Ones. Okay,
I
now,
don't understand why it's ones.
because you need placeholders because there's 3 sets of coordinates. So you have to have 3 rows and 3 columns. Okay, now, here's the deal. How do I start this? Mm-mm.
You would do.
How do I find the determinant? How do I start this?
Oh, you do the cross thing.
Oh,
I do the cross thingy, but what do I need before I can do the cross thingy?
-1.
Yes, copy the first 2 columns. Okay, now I can do the cross thingy, Drew. What's -1 times 43 times 1? 43. What is 41 times 1 times 0? We like those ones, yes. What's 1 times 38 times 0? Beautiful. Oops. Minus, right? What is 0 times -43 times 1? What is 0 times 1 times -1? And what is 1 times 38 times 41? So 38 times 41.
$1,550.
1,558. Okay, now I need to take 43 and subtract from it 1,558. What do you get?
You get
Negative 1,500 and what?
-15.
15. Now, what are you going to multiply it by?
1,000.
What?
I said 1,000.
One. Okay. Now, what are you multiplying that by? -1/2. Good, because I need it to be a positive answer. What do you get?
Okay, so basically you don't actually multiply each one by the
No.
-1.
got 757 points.
757.5.
Wait,
It should have
how do
some
you do
square
the-
miles. What did you say, Drew?
Determine which one you use for the negative or plus.
If this is negative, I multiply by a negative because I need a positive answer because it's area. If this
Oh,
answer
okay.
is positive, I multiply by a positive. Okay? That is what you're doing there. The next thing we need to talk about is Kramer's rule. Okay? And I'm only going to teach you Kramer's rule for a 2x2. We will not do any 3x3s because of two reasons. One, once you get into a further, we can only take it so far in Kramer's rule by hand, but also because I'm not concerned about you doing that complicated of a thing. Once we take it so far, we have to have graphing calculators to do the rest, and we're not going to talk about that, so don't worry. Kramer's rule for a 2x2, that's what we're going to learn. Okay, Kramer's rule. Okay, you can use a determinant. So here's the deal. Kramer's rule uses part of this, uses the determinant, to solve a system of linear equations. Okay, it's named after the Swiss mathematician Gabriel Kramer, who was around from 1704 to 1752, and he uses the coefficient matrix of a linear system. Remember when we had linear systems like ax plus by equals e and cx plus dy equals f? Remember when we had systems and we were solving for two variables by substitution and elimination?
Oh, maybe.
You can use Kramer's rule to solve for it.
Oh, jeez. I don't want to do this.
That's what we're talking
I
about.
don't
We're
wanna
getting
do
there,
this
Drew.
anymore.
Okay? So if you have this, you can set up a coefficient from here. Okay? A coefficient matrix. What that means is I take the leading coefficients of all of these and set up a matrix. So I would have A, B, C, D. You're used to a 2x2 matrix like that. Okay? So I set up a matrix. Okay? That's step one. Set up a matrix. Step two is find the determinant. Okay? Which in this case would be, with these variables, A times D minus C times B. Okay? Find the determinant. You can handle those two steps. Okay? Then, step 3, I'm going to call it replace. And here's what I mean by that. If I want to solve for x, I'm going to replace x with the answers. So I'm going to say EF, and I'm going to say BD, and you put it all over whatever your determinant was. So when you solve this, you're doing the same thing. You're doing E times D minus F times B divided by your determinant. Now you've solved for what x is.
So technically, it's a determinant over determinant.
So
Yes.
the first one finds the y.
No. The first one finds the determinant. So, yes, it's like a determinant over a new determinant. But it's going to give me what x is.
Okay.
If you wanted to find y, I would replace y with the answers and solve. But once I find x, because this is just a two-variable thing, I can take that answer and plug it back in. Okay, and solve. So here's what that looks like number-wise. Let's do
Good.
it like this. Okay, so let's say I have 9x plus 4y equals negative 6. And then my other equation says 3x minus 5y equals negative 21. Okay, step 1, set up a matrix. How do I do that?
9 and 4 and then
3 and not
3
5,
and 5.
negative 5. Okay, make sure those negative signs go with it.
Negative.
Now, from there, what am I going to do? Yes, find determinant. So 9 times 5, negative 5 is minus 3 times 4, which is 12, right? Okay. What is negative 45 minus negative 12?
Negative 57.
Negative 57. That's my determinant.
Wait, minus negative 12?
Negative 45 minus 12.
Which minus 12.
Okay. Now, step 3 is what?
Replace.
Replace. What do you want to replace? Do you want to solve for x or do you want to solve for y?
Why?
I say
Why?
X.
let's do x because it's more
This,
Easier.
yeah,
okay. So if I want to solve for x, I'm replacing these x values with the answers.
Okay.
So what goes here?
Negative six.
Negative 6,
Negative
negative 21, and my y's are still what?
4 and negative 5.
Okay. And what is that all over top of?
The term.
Oh.
Which is what?
Negative 57.
Beautiful. Okay. Now, what is negative 6 times negative 5?
30.
What is negative 21 times 4?
Negative 84.
Negative 84. And that's all over top of negative 57. Now, 30 minus negative 84, blip, blip. What's 30 plus 84? 114. So you have 114 divided by negative 57, which is what?
Negative.
Whoa, whoa, whoa. Okay.
Negative 2. This is your x value.
They need to solve for y. You just plug it back in.
Yes, or you can set up another determinant and replace the y values, whichever you prefer.
So.
I say plugging in is probably easier.
Because that's just too much work to do the determinant.
Well, you could do it
So
again.
y equals negative 2.
Y, that's x. X
Oh, that's
because
x.
we replaced. So x equals negative 2. Okay? If I wanted to solve y doing the determinant, I would replace again. Okay? And this time, my x's stay the same, so I have 9 and 3. My y's become my answers. Negative 6, negative 21, okay?
Do we only have to find one of them?
No, you have to find both.
That's
All over negative 57. What's 9 times negative 21? Negative.
Negative.
And what is 3 times negative 6?
Negative
And it's all over negative 57. What is negative 189 minus negative 18? So plus 18.
Negative 171.
And what is negative 171 divided by negative 57?
3.
So your y equals 3. So your solution is negative 2, 3. I think that's easier than substitution and
Can't you
elimination.
plug in so x or what are the values?
You could. That's what we were talking about, Cole. You can plug in x.
Okay.
Once you get x, you could plug it into one of these two equations, solve
So
for
you don't
y.
need to do the seconds.
You don't have to do it that way. You can. You have to at least do it once.
I feel like doing actually way easier solving.
You're saying.
what setting it equal to?
Yeah,
Yeah.
that's easy. I think it's